What was there before the Big Bang? And if there was not a before, what does that even mean? Try this instead. What is north of the North Pole? Picture a globe in your hands. You can walk north, step by step, until you reach the pole. Then north is no longer a direction you can move. It is not that the Earth has a wall. It is that north runs out at that point. Stephen Hawking loved this picture. He used it to talk about the start of the universe. Maybe before the Big Bang is like north of the North Pole. The word before just stops being a useful pointer there. Time itself could have a shoreline. That shoreline is not a brick wall. It is more like the edge of a map where the paper ends. You are not blocked by a fence. You just reach a place where the word earlier no longer fits the shape of the world. So what do we actually know? The universe is about 13.8 billion years old. Planck satellite data says 13.797, give or take a tiny bit. We can look back and see a baby picture of everything. It is called the cosmic microwave background. Back then, the cosmos was a hot fog. About 380,000 years after the start, it cooled to around 3,000 Kelvin. That was cool enough for light to finally travel far without bouncing off charged stuff. That light is still here. Today it is a faint microwave glow at 2.725 Kelvin. It has tiny ripples, only 1 part in 100,000. Those tiny bumps grew into every galaxy. Now a common mix-up. The Big Bang was not a fireball that blew into empty space. It was space itself, stretching. Think of dots on a balloon. As the balloon inflates, every dot sees all the others drift away. If you run the film backward, the whole surface shrinks together. There is no special center on the surface. Our patch of sky, the part we can see, is big. Its radius is about 46.5 billion light years. That sounds odd since the age is 13.8 billion years, but light traveled while space kept stretching under it. So the distance now is larger than the travel time in years. Let's do a quick tour of the first moments. There is a limit to where our current rules even apply. It is called the Planck time. It is about 5.39 times 10 to the minus 44 seconds. Earlier than that, we expect quantum gravity to run the show. Our usual math breaks. Right after that, many physicists think inflation happened. If it did, it roared between about 10 to the minus 36 and 10 to the minus 32 seconds. Space blew up in size by mind-boggling factors. That stretch would smooth out wrinkles and spread out tiny quantum jitters. By about 10 to the minus 12 seconds, the electroweak era changed. Particles picked up mass. Forces took on the forms we know. Around 1 second, neutrinos slipped free and went their own way. In the first few minutes, the light elements formed, mostly hydrogen, about a quarter helium by mass, a trace of deuterium, cooled more. At 380,000 years, the fog cleared, and that first light set off. If we try to push our best math all the way back, something happens. In classical general relativity, run backward, the equations point to a boundary. Densities shoot up in the math. That is a sign the theory has hit a place it cannot handle. There is a famous result here. It is called the Borde, Guth, and Vilenkin theorem. It says any universe that has been expanding on average, like an inflating one, cannot be extended forever into the past under those rules. In plain words, the classical road looks past incomplete. That does not prove a hard beginning. It just says our map stops. We need a new map for earlier than early, something that blends gravity with quantum rules. One idea tries to soften the edge. Hawking and Hartle called it the no-boundary proposal. Near the start, time could behave like a direction in space. You do not hit a cliff. You slide around a smooth curve. It is like shaving off a sharp paper corner and turning it into part of a sphere. On a sphere, there is no edge to fall from. In that picture, the word before is not a thing you can point to near the start. It is not that there is extra time hiding there. It is that a hard start line is not needed. Another idea swaps the bang for a bounce. In loop quantum cosmology, some models suggest that when density gets close to the Planck scale, gravity changes its tune. Collapse can reverse and rebound. In that case, a prior contracting phase could bounce into our expanding one. No infinite squeeze, no singular point. It is neat, but still waiting for clear evidence. There is also a mirror-style idea. It is called CPT symmetric cosmology. It imagines a time-mirrored anti-universe across the Big Bang. The Big Bang would be a moment of perfect balance. Our arrow of time points one way. The mirror arrow points the other way. Wild, yes, but it is a clean way to make the beginning look like a doorway, not a brick wall. So what parts are rock solid? Two fossils anchor the story. First is chemistry. If you weigh normal matter, about a quarter of it by mass is helium-4, almost everywhere we look. There is also a tiny amount of deuterium, around 2.5 parts in 100,000 compared to hydrogen. Stars alone do not make that pattern. A minutes-old, hot universe does. Second is the afterglow. The microwave ripples at the level of 1 in 100,000 match models, where tiny early lumps grow into galaxies. We cannot see with light before the first 380,000 years. But these two clues, checked many ways, give us a firm floor. You can even see time bend a little in daily life. In 1971, researchers flew atomic clocks on airliners. When they compared them with clocks on the ground, the ticks did not match perfectly. The difference was tiny, but real. Speed and gravity had changed the rate of time. Your phone quietly fixes this too. The satellites that guide it run high above Earth, moving fast in weaker gravity. Their clocks would drift if left alone, so the system corrects for time bending. That is baked into how navigation works. If time can stretch and squeeze here, it is not so strange to think it could begin, and maybe one day end, with the fabric of the universe itself. Time might even be something that emerges from deeper stuff. If so, asking what was before time could be like asking what is north of north. So what does before mean? One option is that it simply does not apply, like north at the pole. In a no-boundary picture, before just runs out. Another option is that before is a different kind of time, like a contracting phase in a bounce, or a mirror time on the other side of a perfect symmetry. Either way, words like before and beginning may be rules inside our universe, not promises about anything outside it. Here is the part I love. We live just 13.8 billion years into this story. That is old enough to read the baby photo. It is young enough to wonder how the first frame formed. If time has a shoreline, we are beachcombers on it. We turn over fossils of light and helium, and we try to trace the shape of the coast. For a blink, you get to be a piece of the universe that knows it began and dares to ask what that even means. That is a rare thing. If this kind of clear, awe-filled space story makes your brain feel bigger, subscribe and drop a like. There are deep dives on black holes, the end of stars, and the size of everything waiting on the channel. Thanks for watching, and see you under the next sky.